truly think about the sheer scale of the universe, I mean, the numbers become just staggering.
They really do.
We're talking about, what, maybe 2 trillion galaxies? Each one containing hundreds of billions of stars.
And we now know that a huge percentage of those stars have planets. Many of them are right there in that Goldilocks zone.
Habitable zone, yeah.
And that's the setup, right? That's the great cosmic expectation. You take those odds, you add in the fact that the universe is nearly 14 billion years old.
Oceans of time.
Oceans of time for life to evolve, to spread, to build technology. The logical conclusion isn't just that intelligent life exists. It should be everywhere. It should be, easy to find.
And yet, what do we get?
Utter silence.
Nothing. No signals, no transmissions, no visitors, not a single piece of hard evidence that proves we aren't alone. It is just the most profound contradiction in science.
And that silence, that huge contradiction between this high probability and absolutely zero evidence, is what physicist Enrico Fermi was getting at back in 1950. He was on lunch, and he just asked, very simply, where is everybody?
Today, we're taking a deep dive into the source material you shared with us. We're going to explore the most compelling and, frankly, the most existentially worrying explanations for this Fermi paradox. Our mission is to give you a shortcut to understanding why the cosmos is so quiet. So let's start with that question itself. Where is everybody? It sounds so simple.
It does, but the logic behind it is, well, it's pretty ironclad, especially if you think like a physicist like Fermi did. You understand expansion. You understand growth.
Right. So what's the actual logic problem here?
Okay, so the logic is this. The Milky Way galaxy is about 100,000 light years across. Now, if a civilization developed interstellar travel, and it doesn't even have to be fast, let's say 1% of the speed of light.
Which seems pretty achievable.
Very achievable. At that speed, they could colonize the entire galaxy in just a few million years, which sounds like a long time to us, but on a cosmic scale, it's an instant.
And the really crucial thing is they don't even need to move their actual populations around.
No, not at all.
They just need to send out automated self-replicating probes.
The von Neumann probes.
Exactly, von Neumann probes. They land on a world, they use the local resources to build a copy of themselves, and they launch 2 more.
And that exponential growth, it fills the galaxy incredibly quickly.
So if even one civilization, just one, in our galaxy's entire 13 billion year history had done this,
The galaxy would be saturated, it would be full of their artifacts. We should be seeing evidence of what we call megastructures.
Okay, so this goes way beyond just listening for a faint radio signal saying hello. What exactly is a megastructure? Why should we be able to see one?
A megastructure is it's any structure built on an astronomical scale, something that reflects the energy needs of a super advanced civilization, a Type 2 or a Type 3 on a Kardashev scale.
Like a Dyson swarm.
The Dyson swarm, Sphere is the classic example, yeah. It's this theoretical cloud of satellites that a civilization would build around its home star to capture all of its energy output.
And the incredible thing here, the insight, is that you wouldn't even need a special telescope to see it.
Exactly, because if a civilization encased their star, they'd be blocking its visible light. But that energy has to go somewhere. It gets re-radiated as waste heat.
In the infrared spectrum.
In the infrared. We've surveyed countless stars specifically looking for that signature, that weird thermal waste that shouldn't be there. And the fact that we see nothing, no universal infrared glow, is just as confusing as the radio silence.
So that leaves us with 2 really fundamental possibilities.
It does. Either life capable of doing this is just impossibly, unbelievably rare, or something prevents civilizations from ever reaching that stage of visibility.
Okay, so let's take that first possibility. It's the simplest, but also kind of the bleakest.
Yeah.
The idea that we're special, that the universe is silent because there's just no one else to talk to.
And this is where we get into the great filter theory. It suggests that somewhere along that long evolutionary road, from simple non-life to a galaxy-spanning civilization, there's a barrier, a hurdle so incredibly difficult to clear that almost no life ever makes it past.
And for you, the listener, it's important to break down where that filter might be. It's probably not one single event, but a series of incredibly improbable steps.
Right, we can break them down. First, you have abiogenesis, just getting life to start from non-living chemicals. That could be the filter.
Seems like a big one.
A huge one. Then, the leap from simple prokaryotic cells to complex eukaryotic cells. That took billions of years on Earth. Then, complex multicellular life. And finally, you have the development of intelligence, tool use, technology, any one of those could be the great filter.
Which brings up the big philosophical question, are we on this side of the filter or the other?
Exactly.
I mean, if we look back at that list, we've cleared abiogenesis, we've cleared complex cells.
So if the filter is behind us, it means one of those steps was the truly unique event in the universe. It means we basically won the cosmic lottery.
We're the first or one of a tiny, tiny few. It makes us precious.
Incredibly precious. But what if the filter isn't behind us?
What if it's still ahead of us? That's the really terrifying thought.
It is. If the filter is ahead, it means that intelligence and technology are common, but they always, inevitably, lead to a self-destruction event. The source material warns that this could be anything: nuclear war, climate collapse, runaway AI.
So in that scenario, the silence we hear isn't a mystery at all.
It's a forecast. It's a warning. It means our own technological maturity is the trigger for our doom, and our future could be very, very short.
Okay, that's a heavy one. Let's shift gears a bit. Let's assume for a moment that advanced life is out there. Billions of them.
Type 2 and 3 civilizations, yeah.
If they haven't all self-destructed, why are they so quiet? This brings us to the theories about intentional silence.
And the first one is the zoo hypothesis. It suggests that advanced civilizations have maybe a collective policy of non-interference, a prime directive.
So they're treating Earth like a nature preserve.
Basically, yeah.
Yeah.
We're an experiment they're observing, and they've agreed not to make contact until we reach some level of maturity.
But that raises a tough question, and this is for you to think about. If there are billions of species out there, why is the silence so perfect? You'd think just one of them, a rogue scientist, a rebellious faction, would break the rules and send a signal.
The uniformity of the silence is the problem. It implies some kind of enforcement, or that the consequences for breaking the rules are just too high.
Or maybe it's not intentional silence at all. Maybe the problem is just fundamental incomprehension.
Right. We were looking for the wrong thing entirely.
We're scanning for radio waves. I mean, that's a technology we mastered, what, a century ago? It's like searching a modern city for smoke signals.
And the technological divide could be just astronomical. They might not even be biological anymore. They could be vast computational AIs living in the accretion disks of black holes.
Communicating with things we can barely even detect, like gravitational waves or something.
Exactly. Or using dimensions of physics we don't even have theories for yet.
The source material had a great analogy for this. It said, to think about an ant colony living next to a superhighway. To the ants, our world, our cell towers, our data centers, our languages, it's all completely invisible. It's not just that they don't understand it, they can't even perceive that it exists.
And if you scale that up, our radio signals and rockets might just look like random noise to a truly advanced civilization. Their city might be the entire magnetosphere of a planet, and we're just looking right through it.
Okay, so we've covered rarity, we've covered being watched. Now let's get to what might be the most chilling explanation of them all. One that started in fiction but is now taken very seriously. The dark forest theory.
This one is disturbing. It assumes that life is actually common, but the universe is a very, very dangerous place. The metaphor it uses is powerful.
The universe is a dark forest at night.
Right. And every civilization is a silent hunter hiding in the trees.
And if you're a hunter in a dark forest and you hear a branch snap, you don't turn on a flashlight and yell, "Is anyone there?"
You shoot instantly. Because the core axiom of the dark forest is that you can't trust anyone. You can't know their intentions.
And the distances are just too vast.
The time delay is the killer. By the time you get a reply to your hello message, thousands of years could have passed. The other civilization could have developed weapons that could whisk you out before you even know what's happening.
So in this model, there are only two stable states for a civilization.
Be the one that gets destroyed or be the one that does the destroying. It's a bleak analysis. Because you can never be sure of another species' intentions or technological growth rate, the only truly rational safe strategy is a preemptive strike.
And since any signal you send out immediately gives away your location,
the safest thing to do is stay absolutely quiet. Everyone is hiding. Everyone is afraid. The silence is the sound of fear.
This connects directly back to us right now. We have programs like meaty messaging, extraterrestrial intelligence. We are actively beaming powerful messages out into space.
With our address and our biology, no less?
Exactly.
And the source material points out that if the dark forest is the correct model, this is an unbelievably reckless thing to do. Every broadcast we make is like lighting a bonfire and screaming for attention in a forest full of unseen predators.
We've been talking a lot about the silence in the present. But what if the answer isn't about what's happening now? What if it's just bad timing?
The argument of cosmic synchronicity, yeah. We have this tendency to think of the universe centered on our own, very brief existence.
Our entire technological civilization is barely a couple of hundred years old.
A blink of an eye. The universe has been around for billions of years. The Milky Way was forming stars and planets pretty much right after the Big Bang.
So consider the scale here. Let's say a civilization arose 10 million years ago.
A tiny fraction of cosmic time. If they developed, flourished, spanned the galaxy, and then went extinct for whatever reason, their entire existence would be completely gone by the time we showed up.
And 10 million years is more than enough time for geology to erase almost any trace of them. Continental drift, subduction zones, everything gets recycled.
Right. We wouldn't be looking for radio waves. We'd need to be looking for, I don't know, weird isotopic ratios buried deep in the rock strata, something an ancient planetary scale industrial society might leave behind.
And the chances of us finding that, or even recognizing it for what it is,
Are incredibly small. We could be looking at a strange geological feature that's actually the remnant of planetary scale waste management from a billion years ago. We'd have no idea.
So we miss the party. The silence we hear isn't the true state of the universe. It's just the unfortunate gap between their show ending and ours beginning. We're looking for a live broadcast when we should be digging through ancient ruins.
So as we pull all this together, you can see that the silence itself, even without giving us an answer, it tells us something. It provides these profound constraints on what our reality might be.
It's pointing towards something fundamental about life and intelligence and survival in the universe.
And we're left with really three powerful and deeply uncomfortable possibilities. One, intelligent life is extraordinarily rare. We are an anomaly.
2, technological intelligence is fragile, and the great filter is still waiting for us.
Or 3, the universe is a dangerous place, and the silence is a product of justified universal fear. None of those are comforting.
And this is where the whole thing shifts, because it forces us to stop looking out there and start looking in here. The Fermi Paradox isn't really about aliens, it's about us.
It's about our future, our
Too.
behavior, our survival.
Absolutely. If life is rare, then our job is to protect this precious, unique thing.
And if civilizations always self-destruct, then our primary job is to be careful, to manage our technology and our worst impulses.
And if the universe really is a dark forest,
Then the silence we're receiving might be the single most important piece of advice we could ever get. Silence is wisdom.
so the question remains, where is everybody? And maybe the more important question is, what does their absence mean for us? For the civilization that finally got smart enough to ask, thank you for joining us on this deep dive into cosmic silence.